When you think of waves, you might think of waves that travel across the ocean. But there are all kinds of different waves, like seismic waves, sound waves, and light waves. Every wave can be represented by a pattern of peaks and valleys, and every kind of wave carries energy from one place to another. You can describe a wave by its amplitude, wavelength, and frequency. Amplitude is the height of the wave, from the middle of the wave to the top of a peak. It is a measure of how tall the wave is. An amplitude can be big or it can be small. Wavelength is the distance from one peak to another. A wavelength can be long or it can be short. Finally, frequency is the number of peaks that pass in a second. A frequency can be high or it can be low. A wave with a short wavelength has a high frequency because it has more peaks that pass by each second. A wave with a long wavelength has a low frequency because it has fewer peaks that pass by each second. Waves with different wavelengths and frequencies interact with materials differently. For sound waves, a wave with a low frequency and long wavelength produces a low pitch. And a wave with a high frequency and short wavelength produces a high pitch. But if you change the amplitude of a sound wave, the pitch doesn't change, the volume does. A high amplitude has a louder sound, and a low amplitude has a quieter sound. For a light wave, changing the wavelength and frequency produces a different type of light. Radio waves have long wavelengths and low frequencies. X-ray waves have short wavelengths and high frequencies. And visible light is somewhere in between. If you change the amplitude of a light wave, the type of light doesn't change, but the brightness or intensity changes. Now you know how waves work, whether they're light waves, sound waves, or ocean waves.